We are now going to solve some more problems in my open math where the polynomials are not given in factored form. To continue to use the sign table to determine if something is positive or negative, we still need to factor, so I'm going to factor my first trinomial. I'm looking for two numbers that multiply to 132 and add to 23. The numbers are 11 and 12. So the trinomial is x plus 11, x plus 12 greater than or equal to 0. This is now my expression factored. And greater than or equal to 0 means greater than 0, positive, or equal to 0, 0. I'm going to do the sign table and see what intervals on the real number line produce a positive or 0 expression. So my number line goes from negative infinity to infinity. My sign table has two rows, one for x plus 11, one for x plus 12. X plus 11 is 0 when x is equal to negative 11. X plus 12 is 0 when x is equal to negative 12. I have three intervals on the number line. I'm going to determine the values of each of the factors. X plus 11 is 0 when x is equal to negative 11, positive when x is greater than negative 11, negative in all intervals where x is less than negative 11. X plus 12 is 0 when x is negative 12, positive when x is greater than negative 12, and negative when x is less than negative 12. My expression, which is the product of the two, is negative times a negative, which is positive. At negative 12, it is 0 times a negative, which is 0. Between negative 12 and negative 11, it is negative times a positive, so negative. When x is equal to negative 11 is 0 times a positive, so that's 0. And when we are greater than negative 11, positive times a positive, this is a positive quantity. Remember, I was looking for positive or 0. Positive or 0 is in this interval or when x is negative 12, in this interval or when x is negative 11. So equal to negative 12 and to the left, or equal to negative 11 and to the right. My interval notation, negative infinity comma negative 12 closed, union, closed at negative 11 comma infinity. For my next inequality, I need to bring everything to the left so that I can compare a polynomial to 0. So as I bring 17x squared to the left, I'm going to write it in standard form. X to the third negative 17x squared plus 72x less than or equal to 0. Factor the GCF, which is x squared minus 17x plus 72 less than or equal to 0. Two numbers that multiply to positive 72 and add to negative 17 are negative 8 and negative 9, less than or equal to 0. This is my expression. Less than or equal to 0 means negative or 0. So I'm going to do my sign table and I'm going to determine where the expression is negative or 0. So let me draw my number line. I need a row for each one of the three factors. My factors are x, x minus 8, and x minus 9. I need to find their zeros and place them on the number line. X is 0 when x is equal to 0. X minus 8 is 0 when x is equal to 8. And x minus 9 is 0 when x is equal to 9. Now I need to determine their values as positive or negative. X is 0 when x is equal to 0, positive when x is greater than 0, and negative when x is less than 0. X minus 8 is 0 when x is 8, positive when x is greater than 8, and negative when x is less than 8. x minus 9 is 0 when x is 9, positive when x is greater, and negative when x is less than 9. Now my expression is the product of three negatives, so it's going to be negative. On the left is the product of a 0 factor and two negative factors, it's going to be 0. Is the product of one positive and two negative factors, that makes it a positive expression. Is the product of a 0 factor and a positive and a negative factor, that makes it a 0 product. Is a product of two positives and one negative, that makes it a negative quantity. Is a product of a 0 factor and two positive factors, that makes it a 0. And in the last interval is a product of three positive quantities, which makes it a positive quantity. Again, remember that I'm looking for minus or for equal to 0. Minus is here, equal to 0, minus equal to 0. So, in general, equal to 0 and to the left, equal to 8, equal to 9, and in between. In interval notation, the solution set is negative infinity, comma 0 closed, union closed at 8, comma 9 closed.